My name is Eric Klaber. For those who don't know me, I was one of the original founders of ObjectShare and then the last two instantiations, and I currently work at Google on the Dart project. Alan here, who's going to talk about some elements of the Dart project, originally went to Carleton University, worked at the Object People for a number of years, where he was the architect of TopLink, which was a very fine piece of work. After the Object People was purchased, he went on to work at Syncom for about 12 years, ended up as the manager of the development group. He also was the developer of another fine piece of software called Glorp that many of us have used over the years. And about a year or so ago, I guess, he left Syncom and joined actually the group that I'm with at Google, working on the Dart project, where he works on internationalization and serialization and other cool stuff. So without further ado, I'll let Alan take it away. There we go. Okay, everyone can hear me?
Yes.
So, thank you everyone. I'm very glad to be here at the hottest conference for the hottest language. Today I'm going to be talking more about my second favorite language, Dart, and web development in general. I've got a fair bit of stuff I'm going to talk about here, so I'm going to skim over an awful lot of details very quickly and sort of, toss off one-liners like, oh yeah, we have multiple inheritance with mixins. And I will also give you the caveat that some of this stuff I don't actually know that much about. I don't really consider myself a web developer, so skimming the surface works for that. So let's talk about the web. A very successful platform, but one which has a few compromises in its design. And when I say the web here, I really mean more like as an application platform. So you have this thing built for presenting static documents and hypertext that's kind of turned into a way of having these single-page applications, very complex things with lots and lots of code in them. Gmail and Google Maps obviously are things that my current company does. And so if we're going to treat this thing as an application platform, what do we want from that? Well, we want widgets. We want a good number of them. We want to be able to add our own widgets, extend them in interesting ways. And the web has lots of widgets, but they're kind of hard-coded in tags. And people write widgets, but what they really mean by a widget is a bunch of stuff stuck together that they consider cohesive. It's kind of like in the older web where it's like, here's a great big picture that spans all these elements, and really what it is 14 GIFs stitched together with careful use of tables and so on. So we don't really have that. We want simple and clean APIs. That's not really one of the web's fortes. You've got JavaScript APIs, which are connected via IDL to stuff that's implemented in C++, and which accreted over many years. We want a model view separation, some kind of variation of MVC. No, we don't really have that. You can fake some of it up, and things like Angular do, but it's certainly not built in. We want encapsulation. No. Portability. Okay, we've got that. The web is extremely portable. There are differences between browsers, especially if you go further back in old versions of browsers. And I learned when I first came to Google the interesting term polyfill, by which they mean hunks of JavaScript you include to compensate for these browser differences. But on the whole, the web is awfully portable. And those portability differences pale in comparison to the difference between different operating systems. And it's portable not just it runs on Windows, it runs on Mac, it runs on Linux, it runs on tablets, phones, cars, refrigerators, set-top boxes. Like it's an extraordinarily portable platform. We want things to start up fast. Not really. I don't particularly do that because you're downloading all the code all the time. And you want things to perform fast once you've done it. Well, we'll download a text format, parse that, create a document format out of that, download this interpreted language, JIT everything. Yeah. And we want a good development experience. Now, in many ways, the web is quite a nice development experience in that you have JavaScript is extremely malleable. You can get things like a console where you can type expressions, including ones that create code. It's kind of Smalltalk-like, but in a lot of ways, not that good an experience. So what I'm going to talk about today is making that better. And I'm going to talk about two different things, because I foolishly thought I could squeeze them both in. One of them is called Web Components, and the other one is the Dart programming language. And I'm going to be talking about them from a Smalltalk-centric point of view. What's good compared to Smalltalk, what's bad compared to Smalltalk, and why should you care anyway. So Web Components is a term that people use. It's really a grab bag of technologies. The first one of which is what people call data binding or model-driven views. And what that really means is providing an observer change update type of mechanism in the web so that I can have a value over here, and when it changes, I'll get told about it. This thing over here will re-render, and if I change it in the web page, the value in the program code will also change. So, composition editor for the web. Custom elements gives me the ability to define my own tags. So now I'm not just limited to the ones that were there originally. Shadow DOM. That's an interesting term, but when I define my own tag, it probably has some internal structure. So I want a tag that's a video player with a scroll bar, and a pause button, and a volume control. I want that internal structure to be hidden. And the fourth piece of this is CSS, which is the way people style things on the web, is kind of this global bag of names, and I don't want other people's names to interfere with my widget, and vice versa. And so when you combine these things together, you kind of do start to have widgets on the web, the ability to define my own elements, have them encapsulated, and have something resembling MVC. Another interesting thing I learned at Google was the catchphrase that there are always two ways of doing everything. There's the way that's deprecated, and there's the way that doesn't work yet. This would be the way that doesn't work yet. This is all work in progress, bits of it, and it's evolving and subject to change. So to look at those in a little bit more detail, model-driven views, you get an annotation you can use in the programming language, and you have some HTML syntax. So if I go over here, I have some normal HTML, and then this double angle brackets time string, which means over here goes the value of the variable time string on which I've put @observable as an annotation. And I can do that not just on variables, I can do it on a function. So this is a Dart function, palindrome. This is Dart syntax that means give me a short function that's just the value of the following expression. Take current time, the string, split it into individual characters based on the empty string, reverse that, join them back together again. And anytime current time changes, my web page will update. Cool. And I can do a Fahrenheit to Celsius converter and all kinds of cool stuff. Custom elements. So in HTML, I can write a tag that says, here's an element, it extends div, I give it my own name, and I give it a parameter called constructor, which in the Dart context means a class name. I write a class, I say it inherits from web component, and then I can instantiate an instance of my converter, give it a ratio, which is probably somewhere in the code that I omitted, with a constant parameter via the data binding. So that's pretty cool. I can write some arbitrarily complex component. I can instantiate it as a single tag. That's neat. Makes it much easier for me to write the HTML for my web page. Unfortunately, I don't just deal with the HTML. Realistically, in these kind of applications, I deal with the DOM. And in the DOM, it all expands out into the union of everything that was in all of these components. So this is an actual little bit of something you can get out of Gmail. You know, lots and lots and lots of nested divs. We're down at the primitives. There's no encapsulation. And this is not just, you know, academic and these people who want programming productivity. The lack of encapsulation, I mean, it makes it much harder to have reusable libraries, but much worse than that, it's a security problem. One of the big issues on the web is what's called cross-site scripting, or XSS for short. And what that really means is if I have HTML or JavaScript from some other source, including, you know, what the user typed in as their name or whatever, and every page has that nowadays, and I don't do it just exactly right, and that escapes, now it has access to everything that's in the page because there's no encapsulation, and I have a problem. And so those kind of bugs are nasty, and people like to exploit them. So we want this encapsulation to get us to the point where something that escapes only has limited access. And so we have shadow DOM. So maybe we have all of this, but big chunks of it are invisible. They're hidden within particular widgets. They can be exposed, but on a disciplined basis. So I can say, what's the API to my widget? And critically, the CSS. So if I say things of this type should be colored blue, and something else in the outer page says they should be colored yellow, that all works. So that's the real 30,000-foot overview of web components. This is something that is being implemented. There's two main implementations right now coming from Mozilla, Firefox, the Xtags project, and at Google there is the Polymer project. Within Dart, it's part of WebUI. These are all doing it all themselves up above the browser level, but there are parts of it that are starting to go into Chrome and Firefox, down implemented sort of for real in the guts of the browser. So revisiting the web, that's definite improvement. We've really addressed the first 4 points that we had there. It's a little more organic looking, but there are still some traps. Portability, we had that to begin with, but there are issues around startup, performance, development experience. And so a lot of that revolves around JavaScript. Lots of people have talked about various issues with JavaScript. How many people here would consider themselves reasonably familiar with JavaScript? Some, but I'll talk a little bit about it. So JavaScript, you know, famously thrown together in 10 days by Brendan Eich. It's in some ways a lot like Scheme, by which I mean that everything's a function. Functions are everywhere. You have closures that don't quite work the way that you and I would think closures ought to work, but they're sort of there. It's kind of like Smalltalk. There are objects. You have pervasive reflection. You can modify things all over the place. The objects don't look quite like what you or I would think objects look like. They're really kind of dictionaries with functions in them, mixed in with the values. It's sort of like Self. There are no classes. It's prototype-based. And kind of like Self, it's a language even harder to optimize than Smalltalk. So for example, in JavaScript, there are no arrays per se. Everything's a dictionary. And an array is really a dictionary whose keys are the print strings of numbers, which is not the most efficient way to implement an array. It's sort of like Perl in that it's very, what I would call, scripty. It has, these values are true, these values are false, and, you know, empty collection is false, it's true. No, empty collection is false, but a collection with things in it is true, that sort of thing. If you spell a variable name wrong, well, you've just declared it. It does type conversions automatically all over the place based on what you thinks you probably meant. And it's sort of like Pascal, or at least the way I think of Pascal back, you know, when I was studying at Carleton, as in you don't have any threads, you don't have any processes, you're using asynchronous I/O, async for anything you don't want to run sort of single-threaded. And if you've read anything about Node.js, that's a server-side thing where they use JavaScript, and they will tell you very eloquently how easy and natural and the right model this async model of programming is. They are wrong. It is a painful model, but it's what we've got. Let's say lots of people have talked about various weaknesses in JavaScript, especially for large-scale programming, and built different languages on top of it. There is a very famous and quite entertaining video that has some of these examples, which I won't go through, but they're interesting semantics. And that comes from a video called What? It's about 5 minutes long from a company called Destroy All Software. It's well worth watching. Some things, come from JavaScript, and it's being built as a real scripting language to do little things attached to a button, not write great huge applications. But there are things about the web that also push things in particular directions. So you're downloading everything every time. So the size of your code really, really matters. And it matters even more if you want it to go to a mobile device. They do things like minification, so before you ship your code anywhere, you run it through something that compresses all the variable names down to 2 characters, strips out all the white space. And this also leads to the problem of libraries. So the JavaScript library is not all that large, or certainly it's missing things that people want. So people write libraries, they write frameworks, and the problem is that the frameworks do things differently, and so they don't really work together, and you can't make a framework that would unify them because that would take too much space. So JavaScript frameworks are famous for listing how many bytes their basic download is on the front page of their website, and there is in fact an interesting framework called Vapor.js whose claim to fame is the amazing amount of functionality it packs into the 0 bytes of download it has. And there are various forks of that framework and ports to other languages. And so this makes it hard to scale up development. The libraries that were written with Backbone don't work with Ember, don't work with jQuery. It starts being hard to scale up, and we've got these components, but now we depend on what particular framework they use. And these are some of the issues you get. So Dart is a programming language from Google which is attempting to address some of these issues. It's our version of a language that targets JavaScript. It's sponsored by Google, but it's an open source project. There are a bunch of non-Google committers as well as Google people. And it will compile to JavaScript, which is like a lot of other things, but it's possibly interesting in also having its own VM. And I think there's some confusion around that. A lot of people have asked me at this conference, Dart, well, does it still only work in Chrome? By which they mean, do you require the VM? Well, the VM isn't in Chrome anyway. It might be at some point, but it isn't right now. So if you're deploying Dart code today, it means you're compiling it to JavaScript, at which point it works in any, what they call modern browser, which mostly means not really old versions of Internet Explorer. There's a distinction I draw between languages targeting JavaScript. There are ones that try to produce nice JavaScript, and there are ones that treat it more like a compilation target. And Dart is definitely in the second class. You can interoperate with other people's JavaScript code, but you're not producing something that is pleasant and that you would want to maintain yourself in JavaScript. So goals of the Dart project: it wants to be structured, be able to have nice tools. This is another problem that arises with JavaScript. We want to have a good development experience. We'd like to have a rich set of standard libraries and opinionated libraries. There's a phrase that you get fairly often with Dart. They say batteries included, which is to say, these are the libraries, and at least for the real core stuff, do it this way. Or write your own library if you really don't want to. But it's driven by performance geeks. The people responsible for the Dart language are Lars Bak and his group in Denmark, the people who wrote V8. A number of them worked on Self. So they have serious performance goals. And one of them is 10 times faster startup than the equivalent thing written in JavaScript, and 2 times faster performance in general. They throw the word predictable in there. So JavaScript, people have done absolutely heroic work in making JavaScript run amazingly quickly for the semantics that it has. but it's a little bit of a minefield that all of a sudden you do the wrong thing and now it slows down a lot because you defeated important optimizations. And what defeats optimizations is different between different browsers and different browser versions. So they want predictable performance that, if this is fast, it will be fast everywhere. And they want to avoid fragmentation of the web. You don't want to become the next VB script. And so the fact that you can compile to JavaScript and run everywhere and interoperate with JavaScript is an extremely important aspect of this. So here is some actual Dart code. And you will notice, of course, that it has unfortunate syntax. But there are some redeeming features. So it has libraries. That's actually something JavaScript, they talk about JavaScript libraries, but JavaScript is kind of like Smalltalk in the sense of, in the core language anyway, there's no concept of a library, there's just code that you bring into the system somehow. So Dart actually has libraries, so I'm going to import the Dart math library, and I'm giving it the alias math. I'm going to define a class. In that class, I'm going to define two variables. One of them is an int, and I'm giving it the name _a. Underscore, that's a convention you often find in JavaScript. In Dart, it's actually enforced. The leading underscore means this is a private variable. The scope of privacy is the library, which is interesting and different. It's definitely unlike Smalltalk. The second thing I've declared is a variable b. So you will notice one of those things I gave a type and one of them I didn't. It works equally well either way. We'll talk about that a little bit more. The next thing under there is a constructor in kind of a C++y style to create, for instance creation method. You give it the name of the class and also an optional name. And there are various other options. The thing I've shown here is a convenience. You write this ._a, meaning when I create this instance, take the parameter and automatically assign it to the variable _a. That makes writing easy instance creation methods really terse and quick. Now I've got a method, but this is a funny method because I've got the word get in front of it. And I say get a, and the right arrow again, which means the short version of a method, and it just returns the variable _a. And so in Dart, fields or instance variables and method access are completely transparent. So I've got a private variable, but now I've written a getter for it, so it looks like there is a variable called a, but it's read-only because I haven't written a setter for it. And I can use that. Directly below that, I've got a toString method, and this also shows, so I'm accessing the variable a in there, which is not really a variable, it's a getter. And I'm using what's called string interpolation, that I write a string, and if in the string I write a $, then the name of the variable or the expression that follows that is inserted into the string at that point. So this writes a fairly normal sort of print string of the object. And again, this is a nice terse form. It's quite convenient. By writing a method with an underscore in front of it, that's a private method, and I'm going to call a method on the library. Well, it's not a method actually, it's a function because the library isn't a class. And so Dart, in addition to having classes and methods, you can write things that are just standalone functions. And they exist in a library. And then finally at the bottom, I've written a more complicated method which uses the long form where I have to have leading curly braces and an explicit return statement. And I compare these objects, and you'll also notice I've got this curly brace tolerance :0. What that means is that this method has an optional named parameter. So Dart has named parameters, which is actually quite a nice feature, especially, I mean, it makes it a little bit more Smalltalky, so obviously that's nice. But in addition, you get things like DOM APIs where you have some C++ish thing that takes 20 parameters. It's kind of nice if they're named and optional, so you only have to put in the ones you actually care about. And the :0 means it has a default value of 0 if you don't specify it. So that's a very quick overview of Dart syntax. The really quick view of Dart in general, obviously the syntax, they say JavaScript, C# influenced, or the whole C* family. However, the object model that's underneath it is very much like Smalltalk. And I skipped down. If you're familiar with a long ago system called Strongtalk, which had optional types, it's very much similar to that. So I can specify that that variable was an int, but that actually has no runtime effect. And one of the things that's similar to Smalltalk and really bothers people sometimes who are coming from other languages is that just because I declared it was an int doesn't mean it isn't null. An int that I haven't initialized, it's not 0, it's null, the same as any other thing you didn't initialize. Influence from self in the application of very sophisticated compilation techniques to make it run fast. And a really interesting thing, because we're compiling to JavaScript, we can't use threads, processes. They've adopted the notion of isolates, very similar to what Erlang does. And so the idea of you have completely separate entities with very lightweight processes, but no sharing between them. And so that's a really interesting thing that I think is yet to be fully explored, but has a lot of interesting potential. And in the language, there are, as they tend to describe it, there are really two main design constraints. There's only two, but they're big ones. One is that it should be familiar to mainstream programmers, thus the JavaScript, C# type syntax. And the familiar also, it has the advantage not just that people can pick it up quickly, but it's pretty easy to port your code onto it from those things. And the other constraint is that it should compile to efficient JavaScript, which is also a fairly major limitation. One of the things that's interesting about Dart is they use the term structure. In the mainstream world, when people think about dynamic languages, they have this idea of them as being like JavaScript or Python or some of these things that are really very free-for-all and with these scripty type of attributes. And so the fact that we have classes, we have libraries, you can't just arbitrarily evaluate code at runtime. And while you have reflection, it's separated out into a separate library called mirrors, rather than being sort of pervasive all the time. That allows you to know when you're using it, which is very helpful in trying to optimize. So it's a lot more like Smalltalk in the sense that there is structure. There is a distinction between accessing a field of an object and accessing an entry in a dictionary. And I think that adds a lot of value. It's also, when a lot of them think about structure, what they really mean by that is it has static types, which it does, and they are useful. But they are useful for things like documentation. They are useful for helping you with auto-completion. They provide you with some helpful warnings, which are not errors, they're warnings. But they have zero runtime effect. There is a checked mode, but if you run in what's called production mode, the types are completely ignored, both by, well, there's no checking of them, they're not used in optimization. And even when you have them, the type system is what people refer to as unsound. Another thing that really bothers static type people. Who here knows what I mean if I say contravariance? Not very many. But yes, you are lucky. In a properly enforced static type system, if I have a type circle, which is a subclass of the type shape, a list of circles is not a subtype of a list of shapes. And so the statement that I have written down here is not valid in a sound type system, like C++, say. It works in Dart. We just let it happen because chances are you know what you're doing. We said toolable. I'm not going to try and actually do a demo, but here is a screenshot of the Dart editor, something that Eric Kleber is in charge of. It's Eclipse-based. We apologize for that. Really, it's the rational choice, especially. It would be nice to write it ourselves in Dart, but we would have had to wait a long time for the Dart language to have matured enough to even begin. Eclipse was there, it worked. This is a very stripped down thing of Eclipse. It starts up quickly. It has relatively few menu items. I actually find it quite pleasant to work with. You can see that it has, here's a list of my Dart files. I can see my source code over here. I can see an outline view of my source code so I can navigate around in it. I'm the only person I've ever noticed using this, but I like it a lot. And over here, we have a debugger where I can see the stack frames, and I can see the values of the variables. I can try it down into them and do many of the things you'd expect to be able to do. The debugger is still, the ability to, for example, evaluate expressions against objects in the debugger is coming soon, but not there yet. And I should also say that a lot of the things that are used in here are also split out, or are increasingly becoming split out into separate components. Like there's an analyzer. It's written in Java, so it runs in Eclipse, but there is a Dart version of it so that you can use it if you really want to be using Vim, or just you want to run the analyzer standalone. Dart does a lot of stuff to help make programming more pleasant. I'm going to throw in one example here. So in web programming, you're dealing with the DOM. The DOM is this thing that's implemented in C++. You're talking via IDL. There's an IDL definition of it. You're talking to it from JavaScript. Things aren't always pleasant. And so here's one simple example. I get the document body child nodes. I stick that in a variable for an array, and then I'm going to iterate through the array. So in JavaScript, I'm iterating through the indexes. But the indexes aren't what you think they are, because arrays in JavaScript are just dictionaries, and this isn't actually really an array anyway. It's what's called a node list, I think. And so the indexes that you have are 0, 1, 2, 3, length, and item. So the first 4 or 5 of those are numbers, and the last one is a function. So this is not nice. If you're trying to do this, you have to do it accidentally. In Dart, I can just say, here is my list. It's document body children. It is of type list of node. And I can write a for loop that just iterates over each element in it. Or alternatively, I can apply more sophisticated things, like I can say list.filter, which means select, and I give it a closure, an unnamed function, so effectively a block, with a type test in it. Yuck, but you end up doing those a lot. So if it's my kind of element, and then I can do a map, which means collect the thing from that element. And so I have a lot of these, I say Smalltalk-like, other people would say functional language-like, collection operations and pleasant ways of working with things. Another thing I should mention, I deleted the slide to save time, but the Dart libraries for working with HTML attempt to be cross-site scripting safe. So if you set the value, the inner HTML of something, it's escaped properly for the context that it's in automatically without you having to worry about it. And hopefully this removes an entire huge category of nasty bugs. Performance. This is something they worry about a great deal. And there's two aspects of that because there are two compilers. So Dart to JS, performance really means getting rid of the code you don't need. There are transformations you can do on it, like inlining things directly in the source code. But a lot of it relates to what they call tree shaking, where you say, I know what your main entry point to this program is, I can see what code from these libraries you need and what code you don't need. And this is particularly good, again, when you have libraries like HTML that have a lot of code in them. Well, you never use these kinds of things, we don't need them. You can also do these transformations on Dart code. So there's a mode where you can say use Dart to Dart. Basically take the Dart code, do the tree shaking, do the transformations, and emit Dart code out the other end again. In none of this are the static types used. So it doesn't matter what you declared something as, they don't trust you anyway. It works entirely on the information that they can verify from what the program does. And obviously this works better if you're not using reflection, or if you're careful with reflection. So a couple of small examples here. So Dart has symbols. which is something that will be comfortable for Smalltalk. If you're referring to a method or a variable or whatever, the mirror system uses symbols as the names. And there is this process of minification, which says take all the names and squish them down as short as possible. The symbols continue to work because they automatically get transformed. But if I want the original name of what this variable was called, there's a thing I can do, say mirror system.getName of this symbol. But as soon as I do that, that means that my program has to keep around the old original long names, at least for the subset of things that I know I might call this on. Another thing you can do, function.apply, which is, it's not quite perform. There is another thing that is more like perform by name. That is more like perform compiled method. Right? At least I know in VisualWorks, and I'm pretty sure in the other dialects, you can sort of get a compiled method out of a class and apply it to a particular instance. And that's more like what this does, which is actually a more convenient thing you can do because getting a compiled method is simpler, and I will mention that. On the VM, they have very aggressive goals. One of the big things for startup is having what they call snapshots. This is something that will be completely novel for Smalltalkers, where you take your program and basically capture the way the memory is at the moment you want, and then you can restart that very quickly. And so this gives you very nice startup, particularly if you end up having this snapshot in your cache, then you can have some additional code on top of it. So this is very nice. But there are lots of other tricks they use for startup. One of the ones that I found impressive, and V8 does this as well, when you download code, the first parsing stage is extremely minimal. It basically does enough to know this is the beginning of a function, this is the end of a function, stash it over there, we will worry about what's inside when somebody calls it. So you don't even actually parse the code completely until a particular method is called. And then you probably produce some quick runtime version of it, and if it gets called repeatedly, you start producing an optimized version of it. So there are things like inlining. There's what they call on-stack replacement, meaning we decided to optimize this method, and we're going to have to change the activation records that are in the middle of running with the old representation. They have bailout code. If this is a small integer, go do this really fast. Otherwise, here, we'll have to do it the slow way. And there is support for single instruction multiple data. So there are array types. I think limited to 4 at the moment, but this is a float array of 4, and any operation of it, goes 4 times faster. And they worry about performance. So this is something you can see on the dartlang.org site. They have performance graphs for a few benchmarks. And this is one in particular for Delta Blue. That's a constraint solver benchmark, widely used, originally written in Smalltalk by Bjorn Freeman Benson, I believe. And so up here, we can see the performance. This runs from February through end of May of this year. And so here's the performance of the Dart VM up here. Here is the performance of a native JavaScript version written in V8. And here is the performance of the Dart version compiled into JavaScript. And this is a particularly fun graph because you notice that round about the end of March, the Dart version compiled to JavaScript started running faster than the handwritten JavaScript. So that's gratifying. Somebody's doing some cool stuff there. So that's a real overview of Dart. There are a lot of things that Smalltalkers will like or find familiar in Dart. So, for example, the type system, and in particular the fact that you can ignore it. There are method cascades. The syntax is a little bit different from Smalltalk. It uses dot dot rather than semicolon. It has a nice property that you don't have to throw on it yourself at the end. But other than that, it'll make intuitive sense to you if you know semicolons. There are reflective capabilities. There are mirrors. There are things called mirror builders, which are dreamt of but don't exist yet or don't even really have a specification. So a mirror lets you do introspection, examine the values, perform methods. A mirror builder would be something that lets you define a class, define a method in the middle of a running program. That does not yet exist, but is hoped for. Compared to JavaScript, there are classes. It's not prototype-based. Some Smalltalkers actually are really keen on prototype-based, but I think for most, classes will be nice. I know I prefer classes. You will probably appreciate that it's fast. There are a lot of sort of congenial scripting type languages that tend to be really, really slow. Dart is really pretty fast and getting faster all the time. There are nice setup collection operations. I showed you a little bit of that. One interesting wrinkle compared to Smalltalk is that they are lazy. So collect, select, and so on. Don't do the computation until you ask for the elements, which occasionally bites you when you turned out you were mutating the state underneath and forgot. But is kind of neat. There's a thing called no such method. And anyone who does not understand what that means understands what it means. I mentioned function.apply, where you can take a function, perform it, and using mirrors you can do a more traditional perform. There are symbols. I mentioned those. Name parameters on methods. Things are quite terse. This is actually something that's a little nicer than Smalltalk. Dave Thomas mentioned yesterday the curl, and the string interpolation is a little bit like that. And Smalltalk's string manipulation is not a real strong point. There are map literals. Maps are dictionaries, which is kind of nice. There are a number of things you can write quite concisely. Numbers. One of the interesting things about JavaScript semantics for numbers is there is one numeric type. It's an integer until you have more than 53 bits, at which point it's a float. Dart actually has, yes, that is one of the areas where Dart actually differs between JavaScript and the VM, is on JavaScript it uses more or less JavaScript numeric semantics, but will warn you when you're suddenly turning into a float. And on the VM, you actually have ints, which are unlimited size integers and floats. You can redefine operators. So there are, you can redefine plus or minus, equality, indexing, and interestingly, call. So there is a method that you can write, which means that now your object behaves like a function and can be invoked as a function, which is kind of nice. On the other hand, there are things that Smalltalkers will miss from Smalltalk. And I led off with a quote from Kent Beck, which I always liked. So, one notable thing, there are no class extensions. And so you find yourself doing a lot of type tests, which are cheaper than they are in Smalltalk, but not less ugly. There are valid reasons why you might not want class extensions. It is a problem when you're trying to have arbitrary components mixed and matched. People are ideologically opposed, but you will miss them. There are no non-local returns. So you can write these things that are kind of like blocks, but return from those blocks means pretend they're a whole thing on its own and return from it. We would have had non-local return if anybody could have figured out how to do it efficiently on JavaScript, I think. That's my conclusion. There are no resumable exceptions. Likewise, the exception semantics are kind of like JavaScript. The stack unwinds when it's thrown. Yuck. Class inheritance. So Dart has sort of class methods, which are called static, because that's a much more meaningful term for it. But, corresponds to C++, Java, and so forth. They are not inherited at all. So there aren't meta classes. Constructors are not inherited. You can do metaprogramming, but it's not as easy as it is in Smalltalk. Become, no. This context, no. Again, this context, again, you really couldn't allow because you could do some really interesting security violations with that. I say generality on class operations. So the example of that is if I say new thing The thing there has to be a literal class name. It can't be a variable. That makes it easier for the compiler to figure out exactly what's being used, but makes it harder to do metaprogramming. There are some things you can do to compensate for some of that. There are some interesting constructor tricks where you can have a constructor that delegates to somebody else, but some kinds of things you might do in Smalltalk become harder that way. Coding in the debugger, or at least coding in the debugger and then continuing from where you were, you can't do right now. That's something I hope we will get to eventually. And it's C-ish, JavaScript-ish syntax, so you're not going to have the Smalltalky property that is kind of its own DSL, and you just evolve your domain vocabulary. Doesn't work as well. And of course, you don't have an image, you can't tweak your own tools on the fly. You can tweak the tools, they're there, you have source code, but it's not the same kind of free-for-all that you have in Smalltalk. There's also a bunch of things that Smalltalkers will find, I would say, new and interesting. So one of them is having standalone functions, which is interesting, and particularly because you have implicit this. So if I do a self-send, I don't have to say, they call self this, I don't have to say this foo, I just say foo, which is actually the same syntax that I would use if I was just invoking a standalone function called foo. Which interestingly blurs the distinction there, and you can sort of kind of do something that might be a class extension, but isn't really. And there's also this thing called closurization, which is very interesting. That says, I write person.toString, and I don't put parentheses after it. What that gives me is a function that if I invoke it, calls the toString method on that person. So I've kind of ripped off the method, and it's given me a closure that invokes that method. And that's actually really quite a handy thing to be able to do. I give examples, but I'm almost out of time anyway. String interpolation, I talked a little bit about that. That makes you be nicely terse. I mentioned I was going to throw off that we have multiple inheritance and mix-ins. It's interesting, yesterday Stephen Pope was saying there were 3 things he really thought were unaddressed issues in Smalltalk. One of them was having some kind of a type system. Well, we've got that. One of them was having some kind of multiple inheritance system, and we have that. And the third one is getting back to running directly on the hardware. Well, we run on an operating system and then stick another operating system on top of it in the form of a web browser, and then run on top of that. So I guess that's regress in that direction. There is a library-based privacy. So it's not the Smalltalk object-based. You can get at the private fields of things that are in your same library. That's kind of interesting. I'm not sure if I think it's good, bad, different. Easy tree shaping. If you've ever used runtime packager or the like in Smalltalk, it's difficult. You don't get it down as small as you might. In Dart, that works really, really well, at least until you start using reflection, which right now doesn't work at all, but we will improve on that. It's a source VM. There are no bytecodes. It executes the source code directly. It's kind of invisible, but kind of cool. Async concurrency is an interesting model. There are things to help with it, but it takes a good deal of getting used to. So why should you care as Smalltalkers? If you're building complicated web clients, it's something that is a fairly congenial language that runs natively in the web browser. It has the support of a big organization behind it. It runs very quickly. It's portable. And possibly most interestingly, it might serve as a compilation target for Smalltalk. There is an interesting project last year by an intern on compiling Gilad Bracha's Newspeak Smalltalk dialect into Dart, which had some unresolved issues like what do you do about non-local returns at the end, but made some interesting progress. And I'm almost out of time, so I'll go quickly over that. Dart is not yet at a 1.0 release, but it's getting there. It targets modern web browsers. That means IE 9 or greater, which means not Windows XP. That's probably the biggest limitation for people, realistically. But hopefully XP is going away soon. Really, kill it. Kill it. There is a Dart VM which can run standalone on the server or on Android. That's more of a proof of concept. And there is a fork of Chrome, which actually has the Dart VM in it, called Dartium, which is really at this point kind of a debugging tool. For deployment, you would be using JavaScript. And it's something that right now is in use. There is a site called Glyph3D that does fancy 3D font manipulations, so it's kind of a really nice, visually impressive demo written in Dart. And it is in use in what I know I can describe as critical internal projects, because somebody else used that in a presentation. I'm never sure what I can and can't say. So in summary, we have two things to help improve the web. We have web components giving us widgets, and we have a fast, structured language that we can have good tooling for, refactorings, good debugging, all the good stuff. Resources. The main website is dartlang.org. There is a try.dartlang.org that lets you write simple programs or even complicated programs in the browser and run them. There are probably the most up-to-date source of information. There were a number of talks at the recent Google I/O conference. One of them talks more detail about the Dart HTML libraries and good things in those. If you watch that talk, you may recognize some bits of mine. And there's also one by Lars Bach and Kasper Lund called Fast Code is Always in Fashion, talking about it in general. And there are some others. There are mailing lists. There are lots of questions and answers on Stack Overflow. And there's a couple of references for web components. The end. Questions? Going once? Okay, thank you very much.